So I'm Lauren Miller. I work for the U.S. Department of Agriculture and their Economic Research Service. Just a standard disclaimer, this is my research and not official government rules or regulations or policies. So I'm going to be talking today about field testing, a native smartphone application for our National Household Food Acquisition and Purchase Survey called Food Apps. So I'm going to go kind of quickly through this. There's more information about what Food Apps is in the handout if you're interested. But essentially, Food Apps collects information on foods purchased or acquired for free, as well as household and individual demographics over a 7-day diary period. So the first iteration of Food Apps was conducted in 2012, which was a while ago now, obviously. And so one of the key findings was that we saw this major drop-off around day 3. And it's hard because if you want to get a good picture of what people are buying or acquiring, less than 3 days is hard without quite a large sample. And so we're hoping the introduction of technology will be able to help in a couple of ways. So first, to reduce non-response as well as to reduce back-end processing time, which for the first collection was really hefty. So as I said, Food Apps 1 was a paper with a CADI component. We've had 2 development efforts since then, so the ADCM as well as the Food Apps field test, which is what I'm going to be talking about today, which were both conducted by Westat. And so we're hoping again that the introduction of this new technology will help with some of the issues we've had in the past. So once households were screened in, a primary respondent was identified. This was ideally the main shopper of the household, and then members within the household were asked to complete a profile questionnaire, an income questionnaire, with some age restrictions as applicable, as well as a 7-day food log. For those that were 11 and under, they were proxied by the primary respondent. There also was an option for other household members to be proxied after day 3. So the debrief interview was 444 households that completed it. Within those 444 households, there were 1,233 individuals. That doesn't mean that they all responded. That's something we're struggling with a little bit, is determining what we want to consider as a complete case. So there were 567 participants that downloaded the Food Logger app. Some of them were also proxy reporters for children and others. This is what the app looked like. So it had a profile, an income questionnaire, as well as the 7-day food log. You can see what the day overview looked like, and you can also see what it looked like when stops. One of the big introductions of the app was this GPS, and so it would pre-populate some of the stops that they could review and say yes or no, I acquired food here. So in this app, we're using a lot of new features. So we're utilizing the smartphone's camera for barcode scanning, pictures of receipt, pictures of food away from home meals, GPS location nudges, as well as GPS to pick up nearby retailers, and extant database matching for item identification, and Google Places for food retailer identification. I'm not going to talk about all of these things, going to be talking about some of them tomorrow. So for our barcode scanning, it was scanned in real time. There were 3 databases that were used in real time. And ideally what happened is the UPC was available in one of the databases, ideally 2 or 3 of the databases, and then the respondent would go on an altered path with less questions if the data was already available. So the implementation, 92% of the items that were scanned were successfully scanned, and so the majority matched to at least one database. 21% didn't match to any databases, which we're still kind of digging into, what those are. And we found that Nutritionix was the most effective for UPC matching in the field test, so 72% of the UPCs that were scanned had a match in the Nutritionix database. So as far as GPS utilization goes, we had really high rates of participation for GPS utilization, so almost 80% of participants turned on the GPS at least one day over the survey week. We also found, though, that for those that had it enabled on day 1, almost 30% ended up disabling the feature by the end of the week, which we think is a signal that in some cases it added burden rather than took away burden for respondents. We also asked, the PR was the only one who completed the initial and the debrief interviews, so we asked them to rate how difficult they thought logging food was, as well as how difficult using the app was. Most people said easy or very easy, But some said difficult or very difficult. And again, this was just the PR, so it's not every household member. So the two main statistically significant differences we found between these two groups was that those who said easy or very easy were younger, and they were also more educated. So 41% had an associate's degree versus only 19% in the difficult or very difficult. So some other considerations that affected user experience. So some users experienced a high number of crashes that may have impacted their usage of the app. We have some really great paradata for this that's allowed us to look into a lot of the specifics. So paradata shows that people who were using phones that had an Android operating system experienced a higher number of crashes, which is just, I think, the way that the app was designed. And then broadband availability and speed, so we used open source Ookla data. The participants who were in rural areas had a much slower upload and download speeds, which makes sense. But for how many screens and how much we were asking them to enter, that may have ultimately changed their user experience. So we also had paradata on help button clicks. So day one had the most help button clicks, which makes sense. There was a small increase towards the end of the week. Maybe people who want to get that incentive, who are logging on towards the end of the week. One of the difficulties we found with looking through the paradata is that it's hard to make inferences about why with paradata. There's lots of great information that can help supplement some of the responses, but some of the specifics are hard. So, for example, with help button clicks, did those people who were struggling figure it out, or did they give up? Like, we can't say that for sure based on the paradata. So some of our biggest lessons learned, so the biggest challenge is getting participants to download the app. So those that did download the app, they enabled their GPS for the most part, they logged in, but there were a lot of households where maybe only the PR downloaded the app and no other household members downloaded the app. So challenges about how do we account for that? How do we get over that? The hope is that since the PR is the person doing the primary amount of shopping, that will still capture most of the food. But how do we consider these households that have just a PR but no other household responses? Again, there's benefits and limitations to paradata. It's a great supplement. It's hard to rely on alone to get information. We found that the UPC scanning was very effective in the app. I think that's great. And again, it tended to work more for younger, more educated populations, as well as older, less educated populations. And I think one thing that's not on here that we're still kind of grappling with a little bit is how to define a complete case. So there's the household level, the individual level, and then each individual has these 2 questionnaires, as well as a 7-day food log, and thinking of the appropriate thresholds to consider a complete case. It's not as easy as just a one-time questionnaire. Here's some information about where I work, and here's my contact, and I'd love to take some questions.